In lesson 8.2, normally I would do similar as I do in 8.1. I would divide the class into 3 groups, and we would discover the cosine law together. Those 3 groups would be assigned the following task. One group would look at an acute triangle with vertices ABC. A second group would be assigned a right angle triangle, or generating a right angle triangle with ABC. And the third group would look at an obtuse triangle, labels ABC. Okay? And what I would have you do again is do some measurements with a protractor and with a ruler to discover what the sizes of each of the angles are and what their corresponding side lengths are as well. And then we would do some fun calculations that are a little more involved than those we found with discovering the sine law. Normally what I would have is you do the following things. I would have you do, what does little b squared plus little c squared equal? What if we take a pair of different sides? What if we take the third pairing of sides here of a squared plus b squared as well? And what kind of answer would we get for each of those? And then I'd have you also, using your calculator, do some cool things like, what if we take 2 times bc times the cosine of a? This is a really interesting pattern because you can see that 2 sides are involved and then a different letter is involved for the angle. And I would have you do all of these calculations as well. What if we took AC with the cosine of angle B, and what if we were to take AB with the cosine of angle C, and what would we discover? And you wouldn't see a direct relationship between these two. They wouldn't be equal to each other just by inspection. But what you would discover is that there's a more complex relationship here. And that complex relationship is called the cosine law. The cosine law enables us to connect 2 side lengths and the angle between them to find a third side length for part 1 of this lesson. Part 2, we'll look at it from a different lens. So the big idea in this lesson is that if I want to know the value of, say, A, I know that its squared value is equal to b squared plus c squared, so these guys here, minus 2 times, whoops, try that again, bc times the cosine of a. You might go, whoa, that's a pretty in-depth relationship, and you're right. Thank goodness there are people who preceded us that found these cool relationships. And you might say, wow, this is a really tough one to remember, but it's not. It's got some cool patterns in it. Take a look at this. The things that are on the outsides of this cosine law relationship are related to the same angle side pairing, okay? And the ones that are on the inside, in here, are related to the other 2 sides. This kind of looks like Pythagorean theorem, and then subtract 2 times each of those sides multiplied by each other gives us this term. So if we kind of recognize that pattern, we can do a similar idea for any other side. We could say, for example, hey, b squared is equal to, we could put cosine b on the outside, and then we could put the remaining 2 sides on the inside. So we'd be left with a squared plus c squared minus 2 times ac, or ca, doesn't matter when we're multiplying, and that would be multiplied by cosine b. We could develop the third relationship too. What if it's c that we want to find the value of? Well, we can put c squared on the outside and cosine c on the outside. And this is equal to, well, what 2 sides do we have left? We have a and b. So we'd have a squared plus b squared minus 2 times ab. Okay, so it's actually a very predictable pattern once you start to see the relationships that are embedded within it. And so this is called the cosine law, part 1. All right, let's show how the cosine law can be used to solve for sides and angles of non-right angled triangles specifically. And today we're looking at the use of cosine law with something called SAS, or side angle side, and I'll tell you in a moment what that means. So in your notes, you have an example that says solve the triangle, and you've learned in previous lessons when you see that, it means that you're being asked to find all angles and side lengths that are not given to you. So again, remember, this is not to scale, it's just to give us an idea of what's going on. So we have a side 13 here, we have an angle of 70 here, and we have 15 here. Now you remember with sine law, we had to have the condition where we knew what I call a side angle pairing. We had to know, for example, this angle and its side length had to be given together to use sine law. That's not the case here. Same thing's true here. We have a side, but we don't know its opposite angle, and here's another side, and we don't know its opposite angle. So sine law cannot be used here. But what we do have is a side angle side scenario, or SAS, side angle side, where the two sides we know have a given angle that is in between them as well. Okay, so how can we use SAS to solve a triangle? Well, again, solving a triangle means you got to find some things. So let's create the grocery list. We don't know angle A. We don't know angle C. And we don't know side AC, or we could refer to it as little b. Okay, so where do we want to start? Well, cosine law would enable us to find B first, okay, because it connects all three sides with an angle that's embedded in there. So let's begin there, and let's find B. From the previous slide, we know that B squared, or this side here, is equal to its angle, which is 70. We'll put cosine 70 over here. And we'll put the other sides in between. So little a right here and little c right here can be used to derive this cosine law. Minus 2 times a times c. Alright, so I want to do this as a general formula first so you can see what's all involved, and now we can sub in some values. So let's do that. So b squared is equal to, our value of a is 13, so we have 13 squared, plus our little c, which has a value of 15 squared, minus 2 times 13 times 15 times the cosine of 70. You might go, whoa, that's a lot of stuff. But the beautiful thing is your calculator can handle this. And in fact, you can punch this all in at once and get right to the value of what b squared is. And let me show you how you do that. So we have 13, and we can use our x squared button to square it, plus 15 squared, minus 2 times 13 times 15 times cosine 70. All of that is in here. I hit equals, and b squared is approximately equal to 260.61. Now on paper, I'm going to shorten the number of decimals that I actually see, but in my calculations, I'm going to maintain all those digits until the very, very end. So what's preventing me from solving for b? Well, the fact that it's being squared is preventing me from solving for b. So what is the opposite operation? Well, it's taking the square root of 260.61 dot, 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 dot. So this is already in my calculator. Let's take the square root of it. Here's my square root button, and I'm going to take the square root of my previous answer. And I get a value now of approximately being 16.1. It doesn't say how many decimal places, so again, our side lengths we're going to assume to 1 decimal place unless you're told otherwise, angles to the nearest degree. So you can cross B off of your to-do list. Okay. Now what's really cool with cosine law is that it can't be used alone. It has to be used with sine law too. So if we want to do it with sine law, we can shorten things up. Now you could keep going and solve for other things using cosine law, but it's long and arduous. So again, we want to do the quickest thing we can. Now that this is 16.1, you have an angle and an opposite side pairing, like we talked about in lesson 6.1. So we can use that now to find angle A with its opposite side and angle C with its opposite side. So it doesn't matter which one we start with. How about we start with A? So let's put what we're trying to find in the top left corner of the proportion. That thing we're trying to find is angle A. So let's put sine of A over little a is equal to, and then let's include our pairing that we know. Sine of 70 over 16.1. Okay, I could actually go back here and I could put the value of A in to save myself a little bit of time. If you're ready to do that, we could put 13 down there. So again, in trying to solve for A, the first thing we have to do is multiply both sides by 13. If I do it on the left, I have to also do it on the right. If I want to solve for angle A, I have to take the inverse sine of both sides. That's going to cancel these operations, so now I can take the inverse sine of all of this. Just like we did in the previous lesson. So angle A is equal to, and if we're punching this in using the display type calculator, we can do it all at once as well. We can go inverse sine times, and let's put all of this inside a big set of brackets. So 13 sine 70, I'm going to close that one because it does a bracket inside the bracket, divided by 16.1, close that bracket, so all brackets have pairs. And I discover that the angle is about 49 degrees. And to the nearest single degree is suitable for a final answer. All right, so to consolidate this point, we use cosine law first because we were given a SAS scenario that enabled us to find the length of the third side. Once we found it, we found a pairing, we could use sine law. And then to find the final angle, we can use an even easier tool. We can find angle C, knowing the fact that all three of them have to add to 80 degrees. So we can do 180 minus 70, which was given here, minus our angle A, which is 49. And we discover that angle C, if we punch it in, is equal to about 31 degrees. And does this make sense? Well, our smallest side should be opposite our smallest angle. Which it is not. So I'm going to have to troubleshoot to figure out why that is not the case. Oh, is it 31? Oh, I punched it in wrong. That's why. I'm going, wait a minute, that should make sense. Let's try that again. My bad. Minus 49. Here we go. 61 makes an awful lot more sense. Sorry about that. So again, smallest angle should be opposite the smallest side. 13 is the smallest side. Medium angle, 61, should be opposite the medium length side. And our largest angle of 70 should be equal opposite our largest side, which is 16.1. So there you go. That's how we can use cosine law to find some things in a triangle that is not a 90-degree triangle. But this lesson focuses in on just when you are given the SAS scenario, or side angle side. Next lesson, we'll look at what happens if you're just given all three side lengths. I'll see you there.